NVIDIA RTX, HPC, NVIDIA AI, and Omniverse. The enabler for Grace Hopper and Grace Superchip is the ultra-energy efficient, low-latency, high-speed memory-coherent NVLink C2C link. With NVLink, that scales from die to die, chip to chip, and system to system, we can configure Grace and Hopper to address a large diversity of workloads. We can create systems with a 2 Grace CPU superchip, a 1 Grace, 1 Hopper superchip, a 1 Grace, 2 Hopper superchip, and systems with 2 Grace and 2 Hoppers, 2 Grace and 4 Hoppers, 2 Grace and 8 Hoppers. The composability of Grace and Hopper's NVLink and the Gen 5 PCI Express switch inside CX7 give us a vast number of ways to address customers' diverse computing needs. Future NVIDIA chips, CPUs, GPUs, DPUs, NICs, and SoCs will integrate NVLink, just like Grace and Hopper. Our SerDes technology is world-class. From years of designing high-speed memory interfaces, NVLinks, and networking switches, NVIDIA has world-class expertise in high-speed SerDes. NVIDIA is making NVLink and SerDes available to customers and partners who want to implement custom chips that connect to NVIDIA's platforms. These high-speed links have opened a new world to build semi-custom chips and systems with NVIDIA computing. NVIDIA has accelerated computing 1,000,000x over the past decade by GPU accelerating algorithms, optimizing across the full stack, and scaling across the entire data center. The computer science and engineering is captured in NVIDIA SDKs. NVIDIA SDKs with CUDA libraries are the heart and soul of accelerated computing. NVIDIA SDKs connect us to new challenges in science and new opportunities in industry. Rapids is a suite of SDKs for data scientists using popular Python APIs for data frames, SQL, arrays, machine learning, and graph analytics. Rapids is one of NVIDIA's most popular SDKs, second only to cuDNN for deep learning. Rapids has been downloaded 2 million times and has grown 3 times year over year. It is used by over 5,000 GitHub projects and over 2,000 Kaggle notebooks, and is integrated into 35 commercial software packages. NVIDIA Rapids for Spark is a plugin for accelerating Apache Spark. Spark is the leading data processing engine used by 80% of the Fortune 500 companies. Users of Spark can transparently accelerate Spark data frame and SQL. Operations that take hours now take minutes. NVIDIA cuOpt, previously called reOpt, is a SDK for multi-agent, multi-constraint route planning optimization, used for delivery services or autonomous mobile robots inside warehouses. With NVIDIA cuOpt, businesses can, for the first time, do real-time planning of thousands of packages to thousands of locations in seconds with world record accuracy. Over 175 companies are testing NVIDIA cuOpt. Graphs are one of the most used data structures to represent real-world data, like maps, social networks, the web, proteins and molecules, and financial transactions. The NVIDIA DGL container lets you train large graph neural networks across multiple GPUs and nodes. NVIDIA Morpheus is a deep learning framework for cybersecurity. Morpheus helps cybersecurity developers build and scale solutions that use deep learning to identify, capture, and act on threats previously impossible. Every company needs to move to a zero-trust architecture. NVIDIA can for sure use Morpheus. cuQuantum is an SDK for accelerating quantum circuit simulators, so researchers can develop quantum computing algorithms of the future that are impossible to explore on quantum computers today. cuQuantum accelerates the top QC simulators: Google Cirq, IBM Qiskit, Xanadu's Penny Lane, Quantinuum TCAT, and Oak Ridge National Labs XATN. cuQuantum on DGX is the ideal development system for quantum computing. Ariel is an SDK for CUDA-accelerated, software-defined 5G radio. With Ariel, any data center, cloud, on-prem, or edge, can be a 5G radio network and provision AI services on 5G to places not served by Wi-Fi. The 6G standard will emerge around 2026. The megatrends shaping 6G are clear. Hundreds of billions of machines and robots will be the overwhelming users of the network. 6G is taking shape around a few foundational technologies. Like networking, 6G will be highly software-defined. The network will be AI-driven. Digital twins performing ray tracing and AI will help optimize the network. NVIDIA can make contributions in these areas. We're excited to announce a new framework, Shauna, an AI framework for 6G communications research. Modulus is an AI framework for developing physics ML models. These deep neural network models can learn physics and make predictions that obey the laws of physics at many orders of magnitude faster than numerical methods. We're using Modulus to build the Earth-2 digital twin. MONAI is an open-source AI framework for medical imaging. The NVIDIA MONAI container includes AI-assisted labeling for 2D and 3D models, transfer learning, and AutoML training. And it's easy to deploy through DICOM. MONAI is used by the world's top 30 academic medical research centers and has over 250,000 downloads. Flare is NVIDIA's open source SDK for federated learning, letting researchers collaborate in a privacy-preserving way, sharing models but not data. Millions of developers and tens of thousands of companies use NVIDIA SDKs to accelerate their workload. We updated 60 SDKs with more features and acceleration at this GTC. The same NVIDIA systems you own just got faster. And scientists doing operations research, quantum algorithms research, 6G research, or graph analytics can tap into NVIDIA acceleration for the first time. And for the companies doing computer-aided design or engineering, the software tools you depend on, from Ansys, Altair, Siemens, Synopsys, Cadence, and more, just got a massive speed up. From firsthand experience, it has transformed our engineering. So, go to NGC, NVIDIA GPU Cloud, and download our SDKs and frameworks that are full stack optimized and data center scale accelerated. The Apollo 13 crew was 136,000 miles from Earth when a faulty electrical wire caused one of the two oxygen tanks to explode. And the now infamous words radioed back to NASA.
Hey, Houston, we've had a problem here.
To work the problem, NASA engineers tested oxygen-preserving and power cycling procedures on a replica of the Odyssey spacecraft. Apollo 13 would have ended in disaster if not for the fully functional replica on Earth. This was an important moment. NASA realized the power of the replica, but not everything can have a physical twin. So NASA coined the term digital twin, a living virtual representation of something physical. Extended to vast scales, a digital twin is a virtual world that's connected to the physical world. And in the context of the internet, it is the next evolution. And that's what NVIDIA Omniverse is about. Digital twins, virtual worlds, and the next evolution of the internet. Over 20 years of NVIDIA graphics, physics, simulation, AI, and computing technologies made Omniverse possible. Simulating the world is the ultimate grand challenge. Omniverse is a simulation engine of virtual worlds. Omniverse worlds are physically accurate, obeying the laws of physics. Omniverse operates at vast scales. And Omniverse is shareable, connecting designers, viewers, AIs, and robots. But what are the applications of Omniverse? I will highlight several immediate use cases today. Remote collaboration of designers using different tools, sim-to-real gyms, where AI and robots learn, and industrial digital twins. But first, let me show you the technologies that make Omniverse possible.
Omniverse technology will transform the way you create.
Omniverse is scalable from RTX PCs to large systems. RTX PCs connected to someone hosting Omniverse Nucleus are sufficient for creative collaboration. Industrial digital twins, however, need a new type of purpose-built computer. Digital twin simulations involve multiple autonomous systems interacting in the same space-time. Data centers process data in the lowest possible time, not precise time. So for digital twins, the Omniverse software and computer need to be scalable, low latency, and support precise time. We need to create a synchronous data center. Just as we have DGX for AI, we now have OVX for Omniverse. The first generation of NVIDIA OVX Omniverse computer consists of 8 840 RTX GPUs, 3 CX6 200 gigabits per second NICs, and dual Intel Ice Lake CPUs. And the NVIDIA Spectrum 3 200 gigabits per second switch fabric connects 32 OVX servers to form the OVX SuperPod. Most importantly, the network and computers are synchronized using precision timing protocol, and RDMA minimizes packet transfer latency. OVX servers are now available from the world's top computer makers. And for customers wanting to try Omniverse on OVX, NVIDIA launchpads are located around the world. Generation 1 OVX are running at NVIDIA and early customers. We are building our second generation OVX, starting with the backbone. Today, we're introducing the Spectrum 4 switch at 51.2 terabits per second. The 100 billion transistor Spectrum 4 is the most advanced switch ever built. Spectrum 4 introduces fair bandwidth distribution across all ports, adaptive routing, and congestion control for the highest overall data center throughput. With CX7 and BlueField 3 adapters and the DOCA data center infrastructure software, this is the world's first 400 gigabits per second end-to-end networking platform. And Spectrum 4 can achieve timing precision to a few nanoseconds versus the many milliseconds of jitter in a typical data center. That is a 5 to 6 orders of magnitude improvement. Hyperscalers will enjoy increased throughput, quality of service, and security while reducing power and cost. Spectrum 4 enables a new class of computers for Omniverse digital twins in cloud or edge data centers. NVIDIA Spectrum 4, the world's most advanced Ethernet networking platform and the backbone of our Omniverse computer, samples in late Q4. Omniverse is a network of networks connecting virtual worlds. The value of the network amplifies when diverse ecosystems connect through Omniverse into a unified workflow. Since last year's GTC, we've increased connections from 8 to 82. We have connectors with Chaos V-Ray, Autodesk Arnold, and Blender. Adobe's 3D Substance Painter, Epic's Unreal Engine 5, and Maxon Cinema 4D. Many developers want to OEM and connect Omniverse directly into their software suite. Bentley Systems is the leading infrastructure design, construction, and management platform. They integrated Omniverse into their Luminar T platform to do interactive, engineering-grade, millimeter-accurate 4D visualization of massive infrastructure digital twins. Bentley's Luminar T with Omniverse is available now. We are launching a major release at GTC, Omniverse Kit, for building Omniverse extensions, apps, and microservices. We're releasing 26 manufacturing format converters to connect industrial workflows to Omniverse. Deep Search is an AI search engine for massive, untagged 3D asset libraries using either natural language or images. Omniverse Replicator, a framework for generating physically accurate synthetic data to train and test AI models. And Omnigraph, a multi-GPU, multi-node compute engine to run data center scale Omniverse applications. And a very big project, Omniverse Avatar, a framework for building avatars or digital humans. Let me welcome back Toy Jensen, an application we built with Omniverse Avatar. Remember, Toy Jensen is not recorded. He's completely real-time, making eye contact, making conversation, and fully animated. Hey, TJ. I got a few questions for you.
Sure, ask me anything.
What is synthetic biology?
Synthetic biology is about designing biological systems at multiple levels, from individual molecules up to whole cells and even multicellular assemblies like tissues and organs to perform specific functions. It is also known as symbio, which stands for synthetic life.
Can you give me some examples?
Some current uses of synthetic biology involve creating biofuels, engineering bacteria with useful properties not found in naturally occurring organisms, developing biosensors capable of detecting environmental toxins, producing biopharmaceuticals, and manufacturing chemicals via fermentation rather than petrochemicals.
What are its medical applications?
Synthetic biology has many medical applications. For example, synthetic biology is being used to develop new vaccines, new antibiotics, and new treatments for cancer.
TJ, that was great. Can you tell us how you were made?
Avatar is a framework built on the Omniverse platform. It lets you quickly build and deploy avatars like me for a wide range of uses. It starts with my voice. It is fully synthesized by Riva's text-to-speech RAD TTS and is also used to drive my facial animation using Omniverse Audio to Face. Next, Omniverse Animation's animation graph is used to define and govern my movement, from hand and arm movements to subtle head and body motion. NVIDIA's open source material definition language, MDL, adds the touches that make my cool jacket look like synthetic leather and not just plastic, while the RTX renderer brings me to life in high fidelity, in real time. Finally, I can listen and talk to you thanks to the latest in conversational AI technologies from Riva and our Megatron 530 billion parameters NLP model, one of the largest language models ever trained. Megatron helps me answer all those tough questions Jensen throws at me. What's also exciting is that I can be run from the cloud, the data center, or any other disaggregated system, all thanks to Tokyo. Tokyo is an application built with Omniverse Avatar, and it brings customer service AI to retail stores, quick service restaurants, and even the web. It comes to life using NVIDIA AI models and technology, like computer vision, Riva speech AI, and NVIDIA NeMo. And because it runs on our Unified Computing Framework, or UCF, Tokyo can scale out from the cloud and go wherever customers need helpful avatars like me, with senses that are fully acute, responsive, and above all natural. I hope you enjoyed a quick overview of how I was made. Back to you, Jensen.
Today's AI centers around perception and pattern recognition, like recognizing an image, understanding speech, suggesting a video to watch, or recommending an item to buy. The next wave of AI is robotics, where AI will also plan and act. NVIDIA is building several robotics platforms: Drive for autonomous vehicles, Isaac for maneuvering and manipulation systems, Metropolis for autonomous infrastructures, and Holoscan for robotic medical instruments. And just as NASA recognized, we will need digital twins in order to operate fleets of robots that are far away. The workflow of a robotic system is complex. I've simplified it here to 4 pillars: collecting and generating ground truth data, creating the AI model, simulating with a digital twin, operating the robot. Omniverse is central throughout. Drive is our autonomous vehicle system. It's essentially an AI chauffeur. As with all of our platforms, NVIDIA Drive is full stack, end-to-end, and open for developers to use in whole or in parts. For ground truth data, we use our Deep Map HD mapping, human labeled data, and Omniverse replicator. To train the AI models, we use NVIDIA AI and DGX. Drive Sim in Omniverse running on OVX is the digital twin, and Drive AV is the autonomous driving application running on our Orin computer in the car. Let's enjoy a ride with the latest build of NVIDIA Drive. We will take you through a highway and urban route in San Jose. You can see what the car sees from the Confidence View rendering. We will navigate complex situations, such as crowded intersections, and your AI chauffeur will be a friendly driving companion.
Welcome, Daniel. I see a text from Hubert asking, can you pick me up from the San Jose Civic? Should I take you there?
Yes, please.
Okay, taking you to San Jose Civic.
Start Drive Pilot.
Okay, starting Drive Pilot.
Can you let Hubert know we're on our way?
Sure, I'll send him a text. I see Hubert.
Can you please take me to Rivermark Hotel?
Okay, taking you to Rivermark Hotel.
Thanks for picking me up.
Definitely. Start Drive Pilot.
Okay, starting Drive Pilot.
What building is that there?
That building is San Jose Center for the Performing Arts.
What shows are playing there?
Cats is playing tonight.
Can you get me 2 tickets for Saturday night?
Yes, I can. You have arrived at your destination.
Please park the vehicle.
Okay, finding a parking spot.
Hyperion 8 is the hardware architecture of our self-driving car, and it's what we build our entire drive platform on. It consists of sensors, networks, 2 chauffeur AV computers, 1 concierge AI computer, a mission recorder, and safety and cybersecurity systems. And it's open. Hyperion 8 can achieve full self-driving with a 360-degree camera, radar, LiDAR, and ultrasonic sensor suite. Hyperion 8 will ship in Mercedes-Benz cars starting in 2024, followed by Jaguar Land Rover in 2025. Today, we're announcing Hyperion 9 for cars shipping starting in 2026. Hyperion 9 will have 14 cameras, 9 radars, 3 LiDARs, and 20 ultrasonics. Overall, Hyperion 9 will process twice the amount of sensor data compared to Hyperion 8, further enhancing safety and extending the operating domains of full self-driving. NVIDIA Drive Map is a multimodal map engine and includes camera, radar, and LiDAR. You can localize to each layer of the map independently, which provides diversity and redundancy for the highest level of safety. Drive Map has 2 map engines, ground truth survey mapping and crowdsourced fleet mapping. By the end of 2024, we expect to map and create a digital twin of all major highways in North America, Western Europe, and Asia, about 500,000 kilometers. The map will be expanded and updated by millions of passenger cars. We are building an Earth-scale digital twin of our AV fleet to explore new algorithms and designs and test software before deploying to the fleet. We're developing 2 methods to simulate scenarios. Each reconstructs the world in different ways. One method starts from NVIDIA Drive Map, a multimodal map engine that creates a highly accurate 3D representation of the world. The map is loaded into Omniverse. Geotypical buildings, vegetation, and other roadside objects are procedurally generated. From previous drives, the dynamic objects, cars, and pedestrians are inferred, localized, and placed into the digital twin. Each dynamic object can be animated or assigned an AI behavior model. Domain randomization can be applied to generate diverse and plausible challenging scenarios. A second approach uses neurographics AI in Omniverse to transform a pre-recorded drive video into a reenactable and modifiable drive. We start by reconstructing the scene in 3D. Dynamic objects are recognized and removed, and the background is restored. After scene reconstruction, we can change the behavior of existing vehicles or add fully controllable vehicles that behave realistically to traffic. The regenerated drive, with 3D geometry and physically based materials, allow us to properly re-illuminate the scene, apply physics, and simulate sensors like LiDAR. The pre-recorded scene is now reenactable and can be used for closed-loop simulation and testing. Drive Map and Drive Sim, with AI breakthroughs by NVIDIA Research, showcase the power of Omniverse Digital Twin to advance the developments of autonomous vehicles. NVIDIA Drive Map, Drive Sim, Hyperion 8 with Orin, and Drive AV stacks are available independently or together as a whole. Electric vehicles have forced a complete redesign of car architectures. Future cars will be highly programmable, evolving from many embedded controllers to highly centralized computers. The AI and AV functionalities will be delivered in software and enhanced for the life of the car. NVIDIA Orin has been enormously successful with companies building this future. Orin is the ideal centralized AV and AI computer and is the engine of new generation EVs, robotaxis, shuttles, and trucks. Orin started shipping this month. Today, we are thrilled to announce that BYD, the second largest EV maker globally, will adopt the Drive Orin computer for cars starting production in the first half of 2023. NVIDIA's self-driving car computer, software, and robotics AI is essentially the same computing pipeline as next-generation medical systems. Let me show you what Holoscan can do for an incredible instrument called light sheet microscope. Invented by Nobel laureate Eric Betzik, light sheet microscopes use high-resolution fluorescence to create a movie of cells moving and dividing, giving researchers the ability to study biology in motion. The problem is that light sheet microscopes produce 3 terabytes of data per hour, the equivalent of 30 4K movies. It takes up to a day to process the 3 terabytes of data. With NVIDIA Clara Holoscan, we can process the data in real time.
Now with Clara Holoscan and NVIDIA Index, we can visualize the entire large volume of living cells in real time as the data is being recorded directly from the microscope. Watching these living cancer cells move about, we can see normal healthy biology and malignant processes at the same time. The fluorescent marker, rendered in blue, marks nuclei, which we see splitting to form 2 cells from 1 cell. A hallmark of cancer is cell division occurring more frequently and with less error checking than normal healthy cells. Using Berkeley's lattice light sheet microscope, the ultimate high resolution allows scientists to see what is hidden to normal light optics, not seen using traditional microscopes. As we zoom in, watch cancer cells display what is thought to be a rare event, even for cancer cell lines. See 1 cell split into 3 cells. This phenomenon has only been reported anecdotally in a couple of scientific publications. Scientists do not yet know what we will see, but this technique, enabled with real-time processing and visualization, now allows the scientific community to discover new, unseen events like this. Let's see what the future has in store.
Clara Holoscan is an open, scalable robotics platform. Clara Holoscan is designed to the IEC 62304 medical grade specification and for the highest device safety and security level. The amount of computation in Holoscan is insane. The core computer is Orin and CX7 with an optional GPU. Holoscan development platforms are available for early access customers today, general availability in May, and medical grade readiness in Q1 2023. Future medical devices will be AI instruments assisting diagnostics or surgery. Just as NVIDIA Drive is a platform for robotic vehicles, Clara Holoscan is a platform for robotic medical instruments. We are delighted to see the enthusiasm around Holoscan and to partner with leading medical device makers and robotic surgery companies. The demand for robotics and automation is increasing exponentially. Some robots move, and other robots watch things that move. NVIDIA is working with thousands of customers and developers, building robots for manufacturing, retail, healthcare, agriculture, construction, airports, and entire cities. NVIDIA's robotics platforms consist of Metropolis and Isaac. Isaac is a platform for things that move. Metropolis is a stationary robot tracking moving things. Metropolis and Isaac platforms, like Drive, consist of 4 pillars: ground truth generation, AI model training, Omniverse digital twin, and the robot with robotic software and computer. Metropolis has been a phenomenal success, has been downloaded 300,000 times, has over 1,000 ecosystem partners, and operates in over 1 million facilities, including USPS, Walmart, cities including Tel Aviv and London, the Heathrow Airport, Veolia's recycling plants, and the Gillette football stadium. And now, customers can use Omniverse to create digital twins of their facilities to drive better safety and efficiency. Let's take a look at how the Pepsi company is using